This is our 1996 automated work cell video. We produced Tic Tac Toe boards. I am John Dersh.
I'm Brian Wardlow.
I'm Alex Lemieux.
I'm Ryan Cassidy.
This is our control panel consisting of an emergency stop, operator start button, a stop light, a running light, air pressure gauge, air pressure regulator, an audible alarm, and an air shut off. Our operator start has a switch on it which allows it to go 2 positions, on and off. If it's in the off position, it cannot be stopped or started unless flipped to the on position. And we'll start the cell. The red light's going to change to the amber caution light. Okay, and now I'm going to press the emergency stop button, which will stop the robot, change the lights, and start the audible alarm. Now I can reset this with the operator start button. Now I'm going to break it with the light curtain. This also starts the audible alarm and stops the robot. This can also be started with operator start.
The electrical disconnect has a safety lock on it. It can be locked in the on or off position. This is our second air disconnect. It can be locked off or on.
In the rear of the cell, we have a physical barrier, we have 2 caution signs, and we have safety tape that outlines the top of the cell. We have external loading with the marbles, described so what marbles load into which feeder. We have a hole here that you can put it's external feeding for the dovetail piece, and we have a handguard in the inside.
Loading compliance, we also have a picture of how the part needs to be fed into the feeder for the board. It all starts with the board feeder, which has a limit switch on the bottom to make sure the board is in place. If it's not in place, the cell will stop and send a screen prompt to the operator telling the board is not in place. Alright, next is the drill assembly, which has a limit switch for extend and retract. Make sure the drill is fully extended and fully retracted. And for the left and right shift, it's also got a limit switch for the left shift and for the right shift. Board holder, there is capacitive procs to make sure the board is in place. Okay, in order to pick up the Dremel tool, we put compliance onto the gripper and on the pin. These pins slide into these holes, which are countersink for compliance, and the pins slide over to make sure there's a solid grip on the board and on the Dremel in order to keep it from torquing back and forth. There's also a chip removal on the robot for blowing the chips out of the side holes and the top holes. There is a proximity switch on the bottom to ensure the bit is present, and there's also a fiber optic inside to make sure the Dremel is present. There's also a retroreflective sensor on the gripper that senses everything that's inside the gripper, from the boards to the stamp and etc. Pancake cylinder is used to release the tool from the tool exchanger. Stamp fixture has a retroreflective sensor to ensure the stamp is in place. There's also an ink pad on the bottom to hold all the ink. The inspection station is 2 push buttons, and the board has 2 storage holes. These just slide over to ensure that the holes are in place. Okay, this is the second inspection station. It has a row of 3 push buttons. The robot takes the board over it and inspects each row of 3 to ensure that they're in place. Rotation station has a limit switch on the bottom to make sure the board is in place, and this can be used to pick it up from any angle like this. You can flip it over and spin it around. There's also compliance on it to make sure the board slides into place. This is our marble assembly. The robot places the board into here, is verified with these fiber optics, After it is verified, the cylinder extends, pushing the board into the chamber where the two marble feeders hold the marbles. They are verified fiber optics across each one to verify low marbles. Okay, the top cylinder extends, allowing the measured 4 marbles to fall into place. It extends back, closing off the holes. Then the bottom cylinder extends, allowing the marbles to fall into the 2 storage holes, and then closes. After that, the dovetail feeder over here fires the dovetail into the board using this large cylinder here, slides the dovetail into place, and then after that, this large cylinder in the back pushes the board out, completing the marbles.
Once the part has been completed at the marble station, the robot takes the part and drops it off in the final part chute. We placed operator safety tape on the outside of the chute.
Inside the drilling station, there's 4 vacuum well holes that collect all the chips from the drilling and that are blown off from the chip removal. Inside the vacuum system, these 4 tubes go up to the top. They all come down to the central plane, which goes out to the vacuum. Our controller is protected by these input fuses to make sure that no voltage goes into the controller, which would fry it. Okay, this is our PLC. Out here are all our relays, numbered and with labels on them explaining what they do. These are all the 120 relays, and on this side is all the 12 volt relays. All are labeled with numbers and explaining what they do. You can see the conduit for all the wire runs. We also have all the cables numbered. Our valve board, which has all the labels on it so you know which solenoid fires what cylinder. And all the dressing is back behind here to keep it safe from anything.
We have a central panduit section for the air tubing and sensor leads that leads back to this side of the cell, going to the controller and going to the cylinders on top of the deck.
Completes our 1996 automated work cell, which makes Tic Tac Toe boards.